Hello. In today's lesson, we're going to look at graphing linear functions when the linear function is actually expressed in what's called standard form. So usually standard form will have a number times x plus or minus a number times y, and it'll be equal to a constant. And we discussed in class, this is in fact a linear function, and our objective is to make a graph. So we need a reminder. A graph is a picture of all the solutions to an equation. So if I'm going to graph this equation, instead of identifying the slope in the y-intercept, because I can't see the slope in the y-intercept when it's written in this form, I'm simply going to find two of the infinite solutions so I can tell which way the line should be going. Easiest solutions to find are at zeros, so I'm going to let x equal 0, and 5 times 0 is 0, so we end up with an equation that says 3y equals 15. So when x is 0, y is forced to be 5 in order to maintain the equality or the truth in this particular situation. So now that I let x equal 0, now I'm going to let y equal 0, which produces an equation 5x equals 15, so x has to be 3. So in order for, let's see here, hold on. In order for this equation to be a true statement, when x equals 0, y must be 5. In order for this to be a true statement, when y is 0, x has to equal 3, otherwise the equation stops being true. That means I found two solutions to my equation, one at 0, 5, which is really easy to plot, it's right there, and the other one at 3, 0. So you draw a line connecting those 2 points, and we understand that this line now should represent all of the solutions to this one equation. Now, to verify that I'm correct, the first thing I'm going to do is observe that this line would have the equation in slope-intercept form of 5 for the y-intercept, minus, because of the downward slope, and a ratio of 5 y's for every 3 x's, so there's a 5/3 ratio. So that's what my line looks like. Now, in order to prove that it's absolutely true, I'm going to take my given equation, I'm going to solve for y, and if I get the same equation, then I'm golden. And indeed it turns out that 15 divided by 3 is 5, so we have 5 minus 5/3 x, which is what my line shows. So now I see here all solutions to the given equation, and I verified using my algebra skills. Another example then, start by finding two of the easiest solutions. One when x is 0, that means y would be negative 12/5 or negative 2 2/5. And then when y equals 0, x would have to be 12, or 2x would be 12, so x would be 6. Then I plot the points 6, 0, 0, negative 2 2/3, and then I'm going to check to see that I actually have this done correctly. So here's what I have. I have two solutions to the given equation. I can infer, because it's linear, that all of the rest of the solutions will fall in line. Now, to check to see that I have the correct two solutions, I'm going to identify the slope of this line. Notice we had to go up 2 2/5 and over 6, which is a 2 2/5 to 6 ratio. I'm going to multiply top and bottom by 5, producing 12 over 30, which gives me 2/5. So the slope of the line is 2/5, the y-intercept is negative 2 2/5, so this must be the equation of the line. Now I go back to my original given equation. I solve for x by subtracting 2x from both sides, and then I'm going to divide both sides by negative 5, and now I just distribute the negative 5, giving me negative 12/5 plus 2/5 x. Negative 12/5 is the same as this, negative 2 2/5. My slopes line up, so everything's good. I have what I need. So apply these principles to the work that you do, and you'll find that graphing lines in standard form is actually a really easy process. This is the gist of the process right here. It takes more work and effort to check your answer, but it is the process of checking that's valuable, not just whether or not you got the right answer that's valuable. So you do this whole process, you'll be fine. I just wanted to add one thing. If I can find the right video here, just bear with me. I think it's right here. And just to demonstrate what might happen if we did our work incorrectly and how we could check our answers. So in this situation, what we had to do was find the two easy solutions. When x equals 0, that means y equals negative 5, and when y equals 0, it means x equals negative 6 2/3 or 20/3. So I plot those 2 points, and now I'm going to check my answer. I could check my answer first by identifying what my line says the slope should be, and the line says we should go down 5 and over 6 2/3. So that's my ratio representing the slope. I multiply top and bottom by 3 to get negative 15/20, which is a slope of negative 3/4. Now, to verify this is right or not, I'm going to go over here, solve my equation for y, and I get 5 plus 3/4 x. Now, I notice the y-intercept is positive when my graph says it should be negative, and I notice the slope is positive when my graph says it should be negative. So obviously something went wrong. The question is, did I go wrong here, or did I go wrong over here? And that's the challenge that we have to face. Which place did the error take place? So what I would do is I'd go back and study all of my work, and at this point I see negative 4 times a number equals negative 20. That means y has to be a positive number. I said it was supposed to be negative. So because of this examination, because of this thoughtful approach, I'm able to see that the work that I did here is where I made my mistake. If I actually did the work correctly, I would find 5 as my y-intercept and a line that negative 6 2/3 0, and so this is the line that I'm supposed to see, and this line more accurately reflects that equation, 5 plus 3/4 x. So make sure you follow the whole process, start to finish, from finding two easy solutions and plotting them, to identifying the slope of the line you plotted and seeing that it matches your algebra when you solve for y. Do that and you'll be great. Thank you for watching.